Hello guys, here Gabi again. Now we are going to talk about design patterns that actually matters in .NET microservices with DDD and Clean Architecture. We know that design patterns are one of the most misunderstood topics in .NET microservices. People either memorize a list of Gov names and force them everywhere, or they reject the patterns entirely and end up with an spaghetti code. In production, both path hurts. We get brittle services, impossible testing, and outchase from avoidable coupling. Okay, so in this video I will try to show you the real priority of the list of patterns that we could encounter here, bounded with .NET 8, DDD, Clean Architecture, and so on, that can keep our microservices scalable, testable, and resilient. Okay, so let's begin. If we can only remember 5 patterns of .NET microservices, please do not remember singleton. We have to remember boundaries, pipelines, and failure isolation. Here is how I think about these patterns in real microservices. We group them by impact, okay? So, or priority, okay? We will have 4 priorities, okay? Priority number 1 could be the core architecture and the application patterns. The second priority could be the DDD modeling patterns, okay? The third priority, integration plus microservices patterns, and fourth priority, data access, object creation, a few Gov classics that are genuinely useful. Okay, we can go through them with concrete examples. In production, the things that are occurring are usually the same. Okay, we need speed, features, endpoints, integrations, but we also need correctness, invariance, idempotency, consistent errors, and we need survivability, downstream failures, timeouts, cascading outchase, okay? And we need that the team scale. New developers should not fear touching the code base. We need the code to be clear, readable, maintainable, and testable, okay? The patterns are how we encode those decisions once, consistently, okay? Across all the service. So, the core patterns for architecture and the application flow could be the use of dependency injection and inversion of control. We already talked about them in other videos, okay? That, for example, VI plus IOC are foundational, are the core of the clean architecture and the .NET microservices, okay? The container builds the dependency graph. We have to remember that the container of dependencies builds the graph, okay, and we code against the interfaces, okay. That's what gives us the decoupling and the testability. Remember, the container builds the graph of dependencies, okay. So for example, remembering the application layer and so on, we know that, for example, the application is what the application layer knows what the business does, what is our need, not the technical details or the implementations, okay? There in the application layer, we define the abstractions, we define the contracts, we define the interfaces, okay? The implementations live in the infrastructure, and the registration, as I said before, happens in the API. So the application layer following DDD and clean architecture, the application knows the what, the infrastructure knows the how, and the registration, the connection of all the dependencies through the container of dependencies, are done by the API layer. Okay, the key is that the application depends on abstractions, not on implementations, okay? Not on concrete integrations. If I need to change providers or the implementations or technical details, we should not change the interfaces or the application. It should be autonomously, okay? Second, CQRS, Command Query and Responsibility Segregation. CQRS means separating reads and writes. It does not necessarily mean two databases. It means two flows and often two models, because the optimal model for writing is not the optimal model for reading, okay? Commands create payment, redeem points, and queries about get points and get status, okay? With MediatR, we can use command queries with a result pattern, right? And the handler, we combined the library MediatR using a handler with command queries and result patterns, okay? Well, the other pattern, MediatR, is about routing the request to handlers, so our API layer does not know the details of our use cases. For example, in a minimal API endpoint, we could use the mediator.send with a command. The handler orchestrates repositories and gateways. And other one is the fourth is the pipeline or chain of responsibility. Okay, as a chain of responsibility, we know that the middlewares exist, the pipeline exists. Okay, the order and the execution of the middlewares are very important because they are sequential when we are handling, for example, exception, errors, request logging, idempotency. Okay, it's needed a pipeline where each component processes the request and forwards it to the next. Each pipeline executed in sequential order is doing the stuff. Okay. So for example, if we want a real life analogy, we are in an airport control. We first go on security, then immigration, and then boarding, right? We have three middlewares, okay, during the pipeline where we have the security, the immigration, and the boarding, okay? Each step adds value and enforces a rule, and the order matters because it is sequential, okay? Next one, as I said before, result pattern, okay? We can use result pattern with problem details as a unified model. Because almost every endpoint eventually needs consistent error handling. So we try to standardize it, the error model, and map cleanly to HTTP with problem details. Okay. Now we pass to the second priority, the DDD. The DDD patterns for business modeling. Okay, this is very important. Here we have the aggregate, the entity or the value object related to DDD. This is how how we model the business. All right, the entities have identity. The value objects does not have the identity. They are defined by their value. Okay. Next one, domain events, but I don't use it a lot. Then we have a bounded context with context map as a anti-corruption layer. Microservices plus DDD is judged by boundaries. Ideally, each microservice is a bounded context. A context map and anti-corruption layer matter because integrations will try to leak external models into our core. So we want a clean translation layer so our domain and application does not get contaminated by providers' DTOs. All right. Third priority, integrations and microservices patterns. The adapter. The application, for example, the application layer is an adapter. It adapts to the abstractions, to that. the adapter pattern is how we protect the model. We adapt the external model to our internal model. Okay. For example, a real-life analogy, an international power plug adapter. Okay. No, sorry. The application is not an adapter. It's a facade. The next one. I missed that. Sorry. The next pattern is the facade. The facade is a simple entry point to a complex subsystem. Using Clean Architecture, DDD with microservices, for example, the application often acts like a facade, okay? For example, a payment service or use case that encapsulates internal steps that hide the complexity from the API layer, right? Then we have resiliency patterns, retry, secure breaker, timeout, bulkhead. That's very interesting, okay? These patterns try to protect us from partial failures and latency cascades. What they actually do, they explicitly call or have HTTP timeouts, retries for transient faults, and with backoff. We have circuit breaker of a downstream, and so on. Then there are other patterns like idempotency, Saga, API gateway, and so on. For example, Saga is for distributed transactions. Saga coordinates local transactions across multiple services, okay, with compensations if something fails. This is useful when we need consistency across services and we don't have a single transaction boundary. For example, in a project I've been working on, we had a strong consistency per service using the unit of work pattern. For cross-service consistency, the typical pattern would be Saga, okay? That it should be orchestrated or choreographed, okay? The next one, for example, when we are designing the systems and so on, we know the application manager from Azure, okay, from Azure. That's an APIM. That's the APIM, the application gateway. An API gateway is the place where it's centralized the authorization, the routing, the rate limiting, and the policies. Okay. The APIM is a simple edge that authorize, that have a centralized authorized routing, retrying policies, and rate limiting. Okay, the APIM, for example, validates the JWT policies and routing to the microservices. Finally, as a fourth priority, we have the data access and object construction patterns. As I said in other videos, we have the repository with the unit of work pattern. The repository abstracts the data access, okay, and the unit of work centralizes, okay. The unit of work coordinates the commit, okay. The repositories abstract the access to the data. We have repositories that access data, and the unit of work, it's a unit that is centralized to coordinate the commit, okay. For example, the pattern of unit of work in .NET ISP, for example, .NET Core, can be used with DB context. The DB context acts as a unit of work. We use save changes per use case. Okay, this keeps the application focused on business flow, not in the persistence mechanics. Then we could have other patterns like factory or abstract factory. For example, we are modeling mocks in the testing and we need to generate data. We can use the factory, or we can have a result pattern that could have multiple states, and we can create n results with different through a factory. Then we have, for example, the strategy pattern, that the strategy pattern could be I don't know, a pattern that, for example, implements a, the a gateway and an abstraction that could have multiple providers that let us change or vary the behavior without huge if-else blocks by swapping implementations. It's selecting what to do in runtime, okay? Then we have the decorators, login, catching, and retrain. So as a payoff, I'm closing this because it's been a very long video. In .NET microservices with clean architecture, the patterns I try to use more are DI and DIP for decoupling, okay? This is the most important. Then CQRS with MediatR for clean command query flows. A pipeline chain of responsibility via middleware and behaviors with error correlation and idempotency. Then repositories and unit of work patterns for persistence. We remember that we have DB context in .NET as emulates or works as a unit of work. Like unit of work is the one that coordinates the commits, and the repositories is that the one that is with that communicates with the data access, okay, and so on. I hope this give you a hand for design patterns, and if you like, subscribe, give a thumbs up, and see you next time. Bye bye.